So here today we're going to talk about the properties of water. So before going to the calculation of pH of different type of solutions, acidic solution, basic solution, the mixture of them, unequally mixing, all the stuffs before going into the deep, we're gonna look about some basic stuff that we are looking from the last some videos. So here we're gonna extend it a little bit more. We're gonna know about the water. What is the water? What is the properties of the water? So first property is acid base nature. Water has both the nature acid and base. So if we talk about water can be treated as Arrhenius as well as Bronsted acid. Now what is Arrhenius acid? Bronsted acid we have seen previously also, and it turns and in terms of base, whenever we are talking about the base, it is Arrhenius, Bronsted as well as Lewis base. So it can't be a Lewis acid because it don't have any empty orbital, but here it could act as a Lewis base because Lewis in terms of base, right? Lewis base, it can act as a Lewis base because it has a lone pair. The all the definition we have seen previously, right? Now in the second term we're going to write about the molar concentration. If we talk about the pure water that do not have pure water means not dissolving any salt, any contamination, whatever you call salt, any iron, cation. So when water is pure, it has some fixed molarity. How it could be? I mean, imagine that molarity of the water is fixed. Whenever I am talking about water, it is supposed to be a pure water. So molarity what does we mean by the molarity? Moles per unit volume. So molarity, let's calculate the molarity of the water. Let's say we have 1 liter of water. That means 1000 milliliter of water, and the density of pure water is 1 gram per ml, right? So molarity, the mass of the water, a volume multiplied by density 1000 into 1, that turns out to be 1000 gram. So the moles of water comes out to be 1000 divided by 18. The mass divided by molar mass, that turns out to be 55.5 mole. So the concentration of water is the moles per unit volume. So 55.5 moles divided by volume is 1 liter. We have taken a sample of 1 liter of water. So the volume is 1 liter. So that turns out to be 55.5 molar. Now concentration of water comes out to be 55.5. So that is the fixed concentration of water. Someone asks you, what is the molarity of the water? That is 55.5 molar. Pure water is 55.5 molar. Now we're gonna focus on the third part, that ionic product of water. What we saw the ionic product of water? The Kw, okay, or self-ionization of water, or an ionic product is something else. I was talking Kw as an ionic, the hydrolyzation constant of water, right? Now, or autoprotolysis of water. So H2O breaks like H plus and OH negative. So the multiplication of concentration of H plus and OH negative comes out to be Kw. When the temperature is 25 degrees centigrade, the Kw is 10 to the power minus 14 and pKw will be 14. As we know, when the temperature is 25 degrees centigrade, Kw is 10 to the power minus 14 and pKw is 14. What will increase or decrease the temperature? Does it remain same, increase or decrease? We know Kw depends on temperature, so when we're going to fluctuate the temperature, when we're going to vary the temperature or change the temperature, the value of Kw will absolute change. But how it will change? It will increase with temperature or decrease with temperature. So when we increase the temperature, we know that the ionization increases, as we've seen previously. So whenever the ionization increases, the concentration of H plus and OH minus will also increase. So then these value increases, the Kw will also increase. Remember, both will increase equally. Equally H plus and OH negative, the concentration of both will remain same. Because 1 mole of H2 will give 1 mole of H plus and 1 mole of OH negative. When alpha is 1. Right now here alpha is not 1. So both should be in equal amount, right? Equal molar. So both will increase same, so Kw will increase. So let's say when we increase the temperature is greater than 25 degrees centigrade. So Kw will also be greater than 10 to the power minus 14. So pKw will be less than 10 14. Because we know Kw is minus negative log of pKw is negative log of Kw. So when we increasing in temperature, Kw also decreases. pKw decreases. Right? So let's take an example. When temperature is 90 degrees centigrade, the pKw value generally in some reference books are given 12. It not necessary to be 12. It can be a little be approximate value, but if they have given, we will see what the value they have given. Now when we decrease the temperature, whenever we are reducing the temperature from 25 degree centigrade, the Kw will also be less than 10 to the power minus 14. So pKw will be greater than 10 to the 14. So whenever we are decreasing the temperature, the amount of the molarity of H plus and OH negative will decrease. So when they will decrease, the value of Kw will decrease. So when the value of Kw will decrease, the pKw will also be less. So now we talk about the multiplication of H plus and OH negative will always be constant whenever it is an acidic solution. Whenever we are increasing the concentration of H plus, the concentration of OH negative will decrease. That turns out to be the multiplication of them will remain constant, because that is Kw that will only be increasing or decreasing with the temperature. So if any, in any aqueous solution, the aqueous solution could be acidic, basic or neutral. It could be acidic, basic or neutral. Product of concentration of H plus and OH negative, that is ionic product of water, will remain constant. The ionic product of the water will always be remain constant. So because it depends only on the temperature, right? So whenever we have a neutral solution, the concentration of H plus will be equal to the concentration of OH negative. That is called a neutral solution. So solution is neutral. Now whenever we are increasing the concentration of H plus, the concentration of OH negative will be less. So that is called the acidic solution. So here pH is less than pOH. pOH will be more and pH will be less, but the summation of both of them will be constant, right? Whenever we are adding in the same solution, and the temperature, it depends only on temperature, right? And when the concentration of H plus is less than the concentration of OH negative, that is called a basic solution. Vice versa, we can say when it is a basic solution that OH negative concentration is higher than H plus. So in that case, pH is more than pOH. So in basic solution, we know pH is higher. So pure water is always neutral at temperature, all at temperature. So whenever we are talking about pure water is always neutral at all the temperature. So whenever we are varying the temperature, the pure water will always be remaining the neutral. Now we know Kw is concentration of H plus in OH negative. So whenever we are talking about the neutral solution, in case of neutral solution, concentration of H plus will be equals to OH minus. So we can say concentration of H plus equals to OH minus, that will be equals to under the root of Kw, because both are the same. We can write OH minus and H plus, then H plus square is equals to Kw, right? So let's do a quiz or some examples, right? If I give you the pH of water at 4 degrees centigrade and pH of water at 25 degrees centigrade, would you guess which pH is higher? So you have to answer that. Then the pH will be higher in the which case? So we know the Kw at 25 degrees centigrade. When we are talking about the 25 degrees centigrade, when temperature is 25, then Kw is 10 to the power minus 14. Then pH will eventually be 7, right? Because H plus will be the under root of Kw. Whenever we are decreasing temperature, the Kw will be less than 10 to the power minus 14. Then concentration of H plus will be less than 10 to the power minus 7. Then pH will be greater than the pH will be greater than 7, because we are taking negative side of the log both. Then negative side will reverse the sign of inequality, right? So then pH will be 7. So there are some more things of water. So that was a very good question. When we are decreasing the temperature, pH of the neutral water increases. Okay, we are talking about neutral water. So there are some interesting quizzes comes out to be the interesting examples, or you can say question illustration comes out to be whenever you are increasing the temperature, pH of the solution decreases. In case of neutral, whenever we are increasing the temperature up to 90 degree, the pH of the solution turns out to be 6, because Kw turns out to be 10 to the power minus 12. So if we take that example, whenever we are increasing temperature, when we increase the temperature up to 90 degrees centigrade, that we have seen temperature is, when the temperature is 90 degree, temperature turns out to be 90 degree. We know we have seen value 10 Kw 10 to the power minus 2. So pH at the solution comes out to be 6, and pOH also 6. So there is a scale when temperature is 25 degrees centigrade, the pH varies from 0 to 14, and at 7 it is neutral, and this part is called the acidic part, and this part is called the basic part. When we increase the temperature to 90 degree, the scale turns out to be 0 to 12. Then the pH, the 6 has a neutral pH. Then the pH is neutral, and this is called the acidic part, and this is called the basic part. So the difference is same. Now if I say when I have the pH 7, when the temperature is 90 degree, would it be acidic or basic? We know that would be simply basic. So remember, these are the good type of questions you may see in your quizzes, right? So K and Kb of water. So water have Ka and Kb also, because it is act as an acid and act as a base also. So whenever H2 is dissociating like H plus and OH negatives, Ka or Kb is a concentration of H plus into OH negative divided by H2. We know when it is losing H plus also, and it is giving OH negative also. So whenever you write it as a Ka or Kb, it should be same, right? So Ka and Kb is right H plus into OH minus divided by concentration of H remains in 55.55. So here Ka and or Kb turns out to be 1.8 into 10 to the power minus 16, because the concentration of H plus OH minus 10 to the power minus 14, that is equals to Kw. So that K and Kb of water is fixed 1.8 into 10 to the power minus 16. That is very, very less. The water doesn't give H plus and OH minus. Very, you can say 10 to the power minus 16 is very less. So water is very, very weak acid as well as a very, very weak base. So if I try to calculate the degree of dissociation of water, now calculate the degree of dissociation of water. We can say alpha of water. So if we try to calculate the alpha of water, so if we see a concentration of H plus, concentration of H plus comes out to be C alpha. So when temperature is 25 degrees centigrade, how concentration comes out to be C alpha? I'll strongly refer to learn the chemical equilibrium first and jump into that part, because that C1 minus alpha, C alpha and C alpha goes to the distribution like that. If we have taken the concentration of water as let's say so C, then it will be C into 1 minus alpha, that will be C alpha. So C alpha is the concentration of H plus. So at 25 degrees centigrade is like this, right? So so concentration of H plus is 25 degrees centigrade is 10 to the power minus 7. 10 to the power minus 7 is C alpha, right? And C is 55.55, and alpha we write it as like that. So alpha turns out to be 10 to the power minus 7 divided by 55.55. So that turns out to 1.8 into 10 to the power minus 9. So it turns out to be 1.8 into 10 to the power minus 7%. So you can say it is very less when you, out of you can say 100 moles of water, only that much moles of water will dissociate. So it is a little bit more than of 0, you can say. So water is very weak acid or it is very weak base, right?